We start by analyzing this fourth-degree polynomial, where we will try to apply the special double cross method. We complete the missing cubic term with a 0x cubed to maintain the order of the equation. We draw our crosses, breaking down the extremes with x squared on the left and the numbers 5 and -1 on the right. We balance the crossed central terms, obtaining 2x and -2x to build our two possible factors. We group horizontally, obtaining x squared plus 2x plus 5 multiplied by x squared minus 2x minus 1. To check if this method worked for us, we perform the distributive multiplication term by term as indicated by the arrows. By canceling the opposite symmetric values, we notice that the reduced expression does not return to its original state. In the second column, we see that the final result does not match, so we mark this first attempt as failed with a red X. Without giving up, we resume our original equation of x to the fourth minus 4x squared minus 12x minus 5. We use a strong mathematical trick by adding and subtracting the term 2x squared so as not to alter the equality. We group the negative terms, resulting in x to the fourth plus 2x squared minus 6x squared. We quickly apply a second trick by adding 1 and subtracting 1 strategically. We join the first three terms in a parentheses and group the rest, isolating a minus 6x squared minus 12x minus 6. Moving to the third column, we transform the first parentheses into a perfect square trinomial of x squared plus 1 whole squared. In the second group, we extract the -6 common factor to reveal another hidden trinomial of x squared plus 2x plus 1.
We compress this new trinomial, turning it simply into x plus 1 all raised to the square. To match the powers of the entire expression, we put the number 6 inside the square, using a square root. We invoke our powerful difference of squares formula, where a squared minus b squared equals their sum times their difference. We open large braces and apply the rule, adding our first bracket with the second and multiplying it by the subtraction of both. To clean the final expression, we distribute the root of 6, inserting it into the parentheses and multiplying the x and the number 1. We arrange the signs, generating two long, irreducible trinomial factors in the last line. Finally, we mark with the green check, confirming that we have successfully solved this complex factorization.